Hello everyone, and thank you for joining the webinar, Introduction to R for Data Mining. Presenting today is Joseph Reichert, Technical Marketing Manager here at Revolution Analytics, and also joining us Kathleen Rohrecker, Director of Marketing here at Revolution Analytics. Today's webinar will run about 50 to 60 minutes, and we'll try and take as many questions as we can. We have a lot of material to cover today. The webinar is being recorded and will be available on our website later today. If you would like to ask a question during the webinar, please open the question section of your control panel, type in your question and click send. Again, we'll try and get through as many questions as we can at the end of the presentation, but of course we'll follow up if we didn't get to your question. I'd like to go ahead and start the webinar with a quick poll. What is your primary analytics platform?
While the participants are answering that question, before we start the topic of data mining, can you just talk about what level of statistics knowledge is recommended for people who want to get started with data mining in R?
Sure. It's always nice to have a good solid background in statistics, because being able to make inferences from data and knowing which tools to use it really helps in the entire process. But a deep knowledge doesn't need to be had, in all areas. I think some knowledge of sampling and sampling techniques, and when you've got a situation where you think you've got a clean data set and what kind of inferences you can make from that, that's sufficient.
Go ahead and share the results of that poll. And I'd like to go ahead and conduct the second poll and see the level of expertise. How would you describe your level of proficiency in R?
So Joe, as we saw from the previous question, about more than half of the participants today don't know R, and yet you're going to be showing a good bit of R code. So what will people get out of today's session?
Well, first off, I think they're going to be able to have the confidence that, to know that they can begin to see what a productive beginning point looks like, and to feel good about the tools and the shape of the R language and how it facilitates making progress.
Thanks.
Great. Thank you, Joe.
Okay.
So I'll go ahead and close this poll and turn it over to you. Thank you, Joe.
So hello, everybody. I'm Joe Reichert, and I'd like to talk with you this morning about data mining and data mining with R. And I have some goals myself here for today. I'd like to convince you, first off, that R is a serious platform for data mining. And on top of that, that Revolution R Enterprise is the platform for serious data mining. But most of all, seriously, I want to help you believe and to learn enough R to do some serious data mining yourself. So what do we mean by data mining? Well, this slide's supposed to indicate it can, depending how you approach it, it can mean different things to different people. Some people start in through some particular application that they're interested in, credit scoring, ad optimization. Some people think of the data mining process, the procedure whereby you acquire data and explore it and clean it and build predictive models. And then there's the algorithm part. What algorithms do you use in order to build those models? And that's where we're going to focus today, on algorithms. And we're assuming that you know something about data mining. It doesn't have to be a lot, but enough to provide you with a context. And this idea of having the right context, I think, is the trick. So in fact, one slide here as an advertisement for R. This is a recent KD Nuggets poll, and it shows that R is out there being used by about 31% of the people who are doing some serious production data mining. It's growing. So you should have some confidence that it's a useful thing to learn. And so what does it mean to learn R? Well, here's the context part. What does it mean to learn French or any other natural language? Well, it depends on what your context is. I mean, if you have some limited goal, maybe it's just to get around Paris on the metro. There's a context. You want to be able to read a map. And it may seem like a very modest goal until maybe if you found yourself lost in the Paris metro, then you know maybe you should put some effort into it. But it's a modest goal. Another thing might be to read a menu, to have a really nice French meal, to be able to read the menu, to understand what's happening in the meal process as the waiter brings you all these different things, and to be able to respond in French and carry on the simplest of conversations with the waiter. I mean, that's a very satisfying experience, and it's something that almost everybody can do with a little bit of effort because the context is so restricted. In a way, you have this technical vocabulary, the vocabulary of food. And then, of course, there are more ambitious goals. Carrying on a conversation is something that every French speaker aspires to, but it takes a lot of time and effort. But nevertheless, on the way, you can do some really interesting things. Now, it's a similar situation with R. So what I'm trying to show here is on my y-axis in mastering R. And down here on the x-axis, I have the Malcolm Gladwell outlier scale. Maybe many of you have read his books where he talks about, among other things, what it takes to be really good at anything. And his thesis is it takes about 10,000 hours. That Bill Gates got where he was today because he spent a lot of time, about 10,000 hours, learning how to code in the early days. And that the Beatles had 10,000 hours of playing together before they actually made their first recording, so they were a pretty tight group. So the first level of skill is to be R aware, and that means maybe you can use a GUI and use some elementary functions. And that brings you to the next level where you're an accomplished function user. And we're going to talk about what an R function is and spend a lot of time on that today. Other levels of skill, to be a programmer, to write your own functions. Then when you really get up there, you might actually aspire to be an R contributor. These are people who write packages or libraries of R functions. And finally, you might become a developer, someone who writes production level code. But my thesis, my point, what I've seen from working with lots of people using R, experts in R, people who are not quite experts but using R productively, that a lot of work happens in this area. A lot of good, solid work, satisfying data mining results can be gotten by being in this R user category and being an expert programmer. So this is where we're going to go today. And to motivate this, let's talk about an aspect of the R language that facilitates this kind of use, and that's that R is a functional language with objects. So here you see a schematic for the LM model, function, that's R's function for building a linear model. And you put in parameters, the function builds an object. And here's a schematic of the object that's produced by the model. And it's basically all the stuff that you would want to have packaged together in the end if you're doing a linear regression. You want to have the coefficients at your hand, you want to have the residuals at hand, you want to have the fitted values. And R works by having functions that do little pieces of work at a time. And the fact that it's a functional language, what that means is that essentially if you call a function with the same inputs multiple times, you're going to get the same answer. So it's not dependent on the where you were before. If you're just as long as you line things up, same input, same function, you'll get the same output. A kind of predictable environment that facilitates experimentation and learning and gives you that sense of a confidence that you know where you are. And there are minimal side effects. So the program, for the most part, our functions don't do things that are extraneous to what you need to have done. The trick, of course, as that last slide indicated, is to know which functions are going to be useful to you. And what I've done out of the thousands of R functions available, and there really are thousands, the R language is organized into libraries or packages. There's about 5,000 of these packages. If you have 20 functions to a package, you can see there are big numbers in terms of functions. But for the most part, there are only a few that are going to be interesting to you for your context. So what I've done here is pick out what I think are the most useful functions for people who are getting started in data mining, and indicated which library they come from. And what we'll do is we'll show a little bit about how these work. Here are two packages that I highly recommend that people become familiar with. The Rattle package has a lot of useful code and data sets to get started in a data mining effort, but it has a GUI associated with it. So a GUI that's just for doing data mining, that provides a context for guiding how you can work. And then there's this package called Caret that's a little more advanced, but it organizes the process of building models and automates much in terms of training models, in terms of looking through parameter spaces to optimize models, and it facilitates progress where Rattle might leave off. So if you start with Rattle and then get familiar with Caret, you're on your way to be able to do a lot of good data mining work. So let's run some code. We'll make all this concrete. And what you should be seeing now is the Revolution's IDE. So this is our development environment. And there's a lot going on here, but most of the action is going to happen on this top screen, which is the script editor. Down here is the console. Here's where we'll see the results. This screen over here basically shows some of the scripts that I'm going to run. And down in this order here, you'll see some R objects as they become available. They'll populate these windows. So the first thing is I have this setup script, and I've already run this. It just basically loads some packages. These scripts will be available, so you'll be able to see which packages I used, and I tried to indicate for the most part, what each package is doing. All right, so let's look now at what R looks like. And the first thing I do is point to a file, a weather data file, and command for reading in a file into a data structure called weather. And let me take advantage of let me find weather down here, and I'm going to use the editor that comes with the IDE to give you a quick introduction to what the data file looks like. So you see we have a date, we have a location, it's all the same location. So these are weather parameters that were collected at in 2007 at the Canberra Weather Facility. And oops. So there are variables of different data types here. We have temperature, which is a real variable. We have some factor variables like wind direction, wind gust speed, etc. And most of the examples are going to be using the columns that represent features or predictor variables to predict whether or not it's going to rain tomorrow. So if this is today, and we have a record. One of the features, whether it rained today, we're going to try to predict rain tomorrow by knowing whether it rained today and knowing a whole bunch of other stuff about what happened today. Yeah. So the first thing I'm going to do is simplify the weather data set I'm going to remove those first two columns. This shows you how, this is kind of a basic concept in R about how to index into a data frame. I got a warning because I didn't get the whole thing. Now we'll run a summary of the data. This is the standard workhorse kind of function in R. It's going to give me the 5-number summary for all those variables. So it's the first look at the data set. And there are other functions in R that give, here's one from the HMIS package that called describe. And it produces a summary in a different format. So lots of times, if you don't like the way the output is, you can find your way to something that's more like you want to see by finding another package and another function. We're going to produce a plot here, and this is a bar plot. We're going to look at the dependent variable, the weather variable. And you can see it didn't take a lot of work with establishing in the plot function. These are the parameters to the function, and it told me what the X label was, the Y axis is going to look like, and I was able to put in text that showed the numbers up here. Basically, that's typical of R, that again, you have functions and that there are ways to modify the outputs of the functions. Next thing, let's look at one of the predictor variables here, sunshine, and I'm going to do a histogram. And this histogram is going to be loaded up. It's going to have on it the results of other functions. Here's something that calculates a density, a kernel density estimation for the distribution of the sunshine. Here's a function that's going to put a rug or the actual locations of the data points down there. And title is going to build a title. So here's in a few lines of code, prepackaged functions, a pretty sophisticated graph of what the distribution. And now let's do a sneak preview here. By packaging these into a user-written function, what I've done here, it's almost all I did was just wrap these different functions that I had as each individual line into a function I call jplot, and I'm going to use that. I'm going to run jplot so it knows about it. I'm going to use that to produce a chart that has multiple explanatory variables plotted. And I'm going to use, this is another workhorse R function that it's called lapply. It stands for list apply. And it's going to work on this data structure V, this vector here, and it's going to apply the plotting function that I just made to all of those 4 variables and produce a graph, 4 graphs on one page. So that's as complicated as we're going to get. So we've hit the maximum complexity here, and you'll be able to look at that on your own later. But I just wanted to show you using primitive functions, packaging them, building your own function. It's not that big a deal. And now I want to show you a look at correlations. Essentially here is the breadth of the library of R. So there's a package that's this is in the rattle package. It's got a correlation function, and it's got a plot correlation function that works with it, and it'll be able to produce, just by stringing things together in the right way, we've got a fairly sophisticated looking graph of many of the variables that are in that data set. And what you see here, it's reinforced in two ways. A positive correlation is a perfect correlation is a line going up to the right. So the skinnier the line, the tighter the correlation. A circle means no correlation. The color also means high correlation for dark colors, lighter correlations for the reds and the pinks. So a visual effect there that it reinforces your idea right away. You can see what variables are related. Okay, now let's move into a clustering algorithm. The first thing I'm going to do is look at the k-means algorithm. And here you see the k-means function. It's going to work on a data set that has all of the functions that are not numerics removed. So here's my lapply function again, and I'm going to apply that to the weather data set. It looks to see, is a variable numeric? If it's not numeric, so this flags it if it is. This says build a data set. It does not include NA omit, do not include variables that have NAs or missing values, and only include things that are numeric. So we're going to run that. The head function here is like you can do heads and tails on a data set, and this just shows you, move it up here. So you see the first few lines of the variables that are included. So let's quickly run the k-means function, and then plot is going to plot the results of that function. And this is kind of nice. So where to go? What we're looking at is for a few variables. We're looking at scatter plots, and the points in the scatter plot are colored by the cluster that they're in. So it gives you a nice exploratory way to get some idea of what you're doing. It wasn't hard to do that in R because the plot function is really smart, and it enables you to do things like color by cluster just by setting a parameter. And I'll point this out. This is another way to index into R. It's very frequent when you have an object, KM here, and the $ in cluster. This gets you the cluster values that were within the object, the KM object. That KM object is sitting out here. Let's see. So here's KM. And you can see these are the different kinds of data that are packaged together to make the object. All right, let's move along to same idea. We'll look at hierarchical clustering. Again, there's a function that does that. So picking the right function about, and we're going to have it run another function that makes it a dendrogram, because I want to be able to make a plot that's visually appealing and gives some idea. So here's a dendrogram plot. It shows you the smaller the lines here, the tighter the correlations. So for a few variables, it shows you a way of grouping things together. All right, let's move on now to a classification problem. RPart is the name of the function. It's in the main R library that does trees, decision trees. And I've indicated here some notes for you about how the decision trees work. Basically, it's a greedy algorithm. It starts in one place. It makes a decision as to whether or not to split on a particular variable. How it chooses which variable to split on depends on the criteria. There's at least two that you can use in RPart, the information gain or the Gini criteria. And I'm showing you here just the logic that it goes through in order to decide how to split. So we're going to take a subset of the data set, and I'm going to put weather into data. And now we're going to make the data set, we're going to split it up into two sub-data sets. This is going to take 70% of the data and take a random sample using the random sample function. And this actually is going to build an index of, so let me run this. So build an index of observations that are in the data set, some to be used for training and some to be used for tests. So if I type in train, what I'm going to get here, these are the indices of the observations that are going to be used for training, and the rest are going to be withheld for the test data set. Simple formula here. This is typical of our syntax for data mining functions. You provided a formula, and I'm saying here we want to use rain tomorrow, and we want to look and build a model of that based on everything else. So the tree model is R, the dot stands for everything else in the model. Now when I do that, I'm going to have a model object. And the first thing I'm going to do that is use the nice draw trees plot function that knows how to draw a pretty plot for a tree. It's also in the rattle. So here we go. So we see what happened. At first it split on pressure at 3 p.m. One side's greater than or equal, the other side is less than or equal to this value. And then it split on cloud cover at 3 p.m. Going down here on the right side, it split on sunshine. And on the bottom you get to see if you go down this tree what the probability of having no rain. Yes, it will rain. It's very high here if you go down this path. So basic way a tree works. You can also interrogate it very easily. The same summary function that I used before to give you the 5-node summary for a simple data set also knows how to work with most models. So this cuts down on the number of functions that you have to learn. So here we see a rather complete summary of the tree model. It shows you what the data set was used. You see here the out of sampling error, and here's a text description of where the splits were done, the primary splits, and of course by comparing this with the picture that you got, it's pretty easy to make sense out of. But the point here is that we've recycled in our function summary that works on simple things like vectors of numbers, also knows how to deal with tree models, and you'll see all the other models we're going to look at. Here's just a function that shows you, so a model and this where part, I put it in leaf. This shows me where each particular observation ended up. That might be good for debugging. Here we have the predict function. Predict is also a workhorse function. It knows how to deal with different models, and it will predict the results of the model based on the data in the weather data set that was withheld. Here's the test data. And we're going to then look at, build a little what we call confusion matrix. And I have a helper function here that just calculates overall error. So if I run this code, so we get a look at, we hand built the confusion matrix. Later on I'll show you some functions that automatically built it. But so the actual, observations, there were 74 in which it did not rain in actuality, and the model predicted it would not rain. There was also 15 times observations where it did rain, and the model predicted rain. And these guys over here are where the errors were. You can see the overall error rate was about 19%. Not bad for an off-the-shelf attempt at model building where we didn't do much in terms of optimization. I'm going to build an ROC curve, a receiver operating characteristic curve. it's going to use some functions. This prediction function is in the ROCR package, and it's going to put things together again with the same old plot function. And we've got a curve here against the true positives against the false positives. And these are kinds of things that you may, probably already familiar with, and the goal here is to show you how to get at them in R. Let's skip over the boosted tree and look at random forest. So random forest, as you know, is an ensemble algorithm. What it does is it puts together, it builds lots of trees. It introduces randomness in a couple of ways. Each tree is done with a randomly sampled number of variables, and then within the tree there's a bag of observations that are used to build the tree, and some observations are withheld. That strategy allows the random forest algorithm to check itself, to be able to determine what the out-of-bag error rate is. So for each tree, it builds an estimate of how good it was in doing predictions. Again, just a little notes to remind you about how the random forest model works. And this is it. I mean, we already have enough machinery just to run the random forest model without doing much work, because I built the indices for the training set and for the test set. I can tell it here that I'm going to run the random forest model with this formula. Here I'm using the data. It's the data set, but only those indices that we flagged to use for training. Trees, we use 4 variables at each split, etc. So this thing says I'm going to keep track of variable importance, and we're going to look. It has a really nice feature, the R random forest function here. This rough fix indicates what action to take if you have missing values. So it's going to use the median, in this case, to impute missing values that may be there. And I'm going to get the output of run that model and get the output of the model just by printing it out. So here's the random forest. These are small models, so you see everything's running almost instantaneously. Again, a summary of the model, and here's the out-of-bag error rate that I mentioned before. Here's the confusion matrix. It automatically, our functions, they automatically provide it. Here I indicated for you some interpretation of what the confusion matrix means. So over here you see what this 4% means, that if you take these ratios, 9 out of the times it predicted yes over the sum of the what's down here in the denominator, you see that the model predict rain when there was none, 4%. Well, let's move along. You can we have just some code to give you error rates. This shows you what the minimum error index was. So all of these models had minimal error rates. Pretty self-explanatory. Here I'm going to list the importance. This is another feature of R. We turned on that. Let me make sure I get everything. We turned on the feature to show you importance. So here's importance of the variables. You read this going from left to right. This score indicates how much this particular variables contributed towards making the model. So you start down here, and it build up this way to decide which variables that want to include in your model. We'll plot the error rate against the number of trees. So here's error rate. This is the total error rate down here. You can see that it flattens out. Sometimes it increases. So you might want to use this kind of thing to adjust the number of trees you're building. Here we're evaluating the performance on the test set, and I'm going to skip that in the interest of time. And I'm also going to run this very quickly. Random forest doesn't prune its trees. And for any individual tree, you might want to, well, here's a model built on a balanced tree. So remember when we looked at our histogram, there were a lot more zeros than ones. Sometimes you can improve the performance of the model by taking a sample that includes roughly as many zeros as ones, and that's what this function, this parameter setting for random forest did, and we did get a little better model. And I'm going to move quickly here to support vector machines, a kind of classifier. What we're going to do here is show you some of the things from the Caret package. So I'm going to build my support vector machine model. Then over here, this can do the kind of thing to predict the results in the test set. I'm going to skip that, and I'm going to go through now and start off a simulation. This is a function from the Caret package that is automatically going to go through and decide what's the optimal combination of parameters to in the training of the model. And this using parallel computing here. So the random forest train function automatically has built in it a way to do parallel, and it's very easy to use. You just have to register the parallel workers. I'm registering the parallel back end. I have 4 cores on my machine here. I'm telling it to use 4. So let's kick this off, and it's going to take a little while to run. I'm going to show you it running with my task manager, but now would be a good time to look at another polling question.
Great, thank you.
So Yanni, we got about...
I'll go ahead and launch it. How many analytic... Go ahead. Sorry.
No, please go ahead, Yanni.
I was just reading the question. It's okay. Go ahead, Kathleen.
So Joe, it sounds like data mining is all about understanding the structure of your data. Why is that so important? Why is that such an important place for people to start in getting involved with R?
Well, the structure of the data is going to be intimately related to not only the kind of answer you get, but how you might approach getting an answer. So there's sometimes the structure itself will give you a clue as to the kind of models you want to build, and it'll indicate whether or not maybe you're going to have an opportunity to sample and be able to use techniques that will easily fit in the memory of your machine, or whether or not you have to look for alternatives to use more data. So it's structure indicates many things, but in our context here of data mining, it's really important to get an idea of what's going to work for you.
Mm-hmm. Thank you.
Thanks, Joe. And Joe, there's been a bunch of questions coming in asking about the data sets that you're using in your examples and if they'll be available.
Right. So this data set is available in the Rattle package. If you load the Rattle package into your R, this weather data set comes up, along with another very nice one from using audit data.
Great,
so
thank you.
I made a point of using something that's really easy to get to.
Great, thank you, Joe.
So should I go on?
Yes, go ahead. Mm-hmm.
So these are the scripts that we looked at, and now I want to, something that I'd like to allude to here is the challenges you might have with really big data. So once a person gets started and gets some success, there's an insatiable appetite to look at data, and really big data presents a couple of problems. For R anyway, all of the data and the models have to fit into memory. And And it's also the case, as we just saw, that you might want to be able to use parallel computations in order to make your models run in a reasonable amount of time. So the combination of big data and parallel computations may influence you read a chunk of data, the external memory algorithm produces an
I'm
answer.
sorry, Joe. There was probably about 20 seconds there where we lost audio. So you might want to go back and reintroduce
Yes,
the slide.
I'm hearing hissing too in the...
Yeah, I hear that as well. But I think if you just speak a little bit louder and cover the slide again, I think we'll be good.
Okay, so now you know how I sound with a hiss. So here we have, what I'm trying to do is motivate, so what do you do when you get stuck with more data that than you can handle? One thing you might use is the RevoScale-R package in Revolution R Enterprise. It works by using external memory algorithms. These are built-in algorithms that you run from your R environment that don't work directly on the data in memory. What they do is they work on data in a file, in this case a binary file format. The algorithms read a chunk of data, they bring it into memory, they just work on that chunk, they provide some intermediate result, and they chunk through the whole file, and at the end produce a final answer. They do that in parallel too, so all those algorithms are inherently parallel. Here is a list of some of the algorithms that are useful that are in the RevoScale-R package for data mining. And what I would like to do is, before we talk about the future, let me give you an indication of how they work. So now I've got a script, and I won't run all of this, but basically what we're going to do is use RevoScale-R algorithms to predict a mortgage default from a fairly large data set. So let me have a look at the data set for you. And what I'm doing here is running a function. Anything that begins with an Rx is a function from the RevoScale-R package. And what I'm doing is interrogating the metadata that was stored with the file. And here's where that started. So it's just showing you the variables that are in my mortgage file. I've got 1,000,000 rows. I've got 6 variables. And here's the beginning of what the data looks like. So we're not doing weather anymore. We're in credit scoring. So here's a credit score, house age, years employed, current debt level. There's the year that the measurement was taken, and whether or not the person defaulted on a loan or not. And we're going to see if we can't build a classification model to determine whether or not somebody's going to default. And I have in here the steps that we went through. So this code, first of all, you want to build training and test files. And I won't run these, but all the code is here to do it. So here's how to build a training file. And what I want to show you here is that we have this function called DataStep, Rx DataStep, that makes it easy to take one of these external memory files and build another one, manipulating data along the way. And the thing that this DataStep is doing is drawing random observations from a uniform distribution, and with 10 slots. So what I can do is then establish whether or not which variables I want to use for my training and which for the test set. And here I'm saying, okay, If things are less than 9, I'm going to put it in the training file. I'll just run this histogram to show you that what the outcome point, the default variable looked like in the training set, and you can see it's a very unbalanced kind of thing that like we had before, and these are problematic, but we're not going to have any problem with it here. I'm going to use the logistic regression function as a classifier, and here's I'm going to time this so we can see how long it takes. Here's the RxLogit. It builds a logistic regression. I'm doing a regression of default against house age, year, the credit score, the years employed, and the debt. And because these are numeric variables, but I'm going to use that F function to turn them into factors on the fly. And you can see now it's starting to chunk through the data. So, and also the algorithm that's used, it's an iterative least squares algorithm. So what it has to do is make several passes in order to converge to a final solution. It's a very complicated algorithm, very sophisticated, but it's working through this data in a reasonable amount of time. So here you see a million rows processed in 27 seconds. And we have a similar function. RxPredict is the analog of the predict function that we used before for the open source R functions. Here RxPredict serves a similar function in providing predictions for data on a new test set. So this is data that we withheld. And you can see that I'm taking the model object here. I'm using the test data to do the prediction, and I'm putting the data back into the test file. I already ran that. And this shows you now I have a new variable with a prediction default. And that can be used to generate the confusion matrix. And we'll do that using this RxCube function, which is very nice for doing tabulations in long form. So here we have a long form tabulation of the confusion matrix. Instead of a 2x2 table, I've actually broken out all 4 combinations. And I like this better, but it's easy to get to with ReboScale-R. So you see here when there was no default and predicted no default, there's where most of the people lie, and the percent rate is 99% here. So this particular data set actually is very easily, the model had no trouble doing predictions. And we'll run a k-means analysis to see why. Of course, the k-means is something that you might have done in a preliminary step. Once again, it's chunking through all of the data. It has to do all 1 million rows, and it's doing some complicated things. But here you see I asked it for 2 classes. I'm plotting just a few of the variables just so we can see them really clearly. And you can see that the separation is starting to happen here. Some of these variables easily separate into 2 classes. So by doing this kind of analysis first, you could have some confidence that your prediction algorithm, maybe almost any prediction algorithm, would have some success. In any event, that was a quick look at ReboScale-R and how it can be used on a data set that might not fit into the memory of your little laptop. It certainly strains the boundaries of what I can do here on with normal R on that data set. but I can easily process it with RevoScale R, and as you can see, the syntax, the idea of using basic functions, the way of interrogating it and building test and training files all follows through. It's the same R way of doing data mining. So that's it in terms of my code. As I mentioned, the data sets are available for you to play with, and the last thing I'd like to do is just give you an idea of what to do next. And I've prepared here on the slides some links that are particularly important. So the first thing is you want to go and look at the machine learning task view in R, and this is just a fantastic treasure trove of data mining algorithms. They're all listed there. They're easy to get to. There's a data mining website that I recommend you look at, and there's code in there to build these kinds of maps here. There's a visualization. If you haven't already looked at this, there is a place to go out on the web and get ideas for how to build all kinds of R graphs, and they provide the code. This is just an open source project that people contribute to. Oops, we don't want to do that. There are blogs, Revolution blog. There are other bloggers, R bloggers. Stack Overflow is a place to get help. There's a daily language tip. There's an Inside R website. And for searching for R, there's actually a website called RSeek that is geared towards searching for R functions. So Google does a pretty good job, but this takes out the noise and helps you to zero in on R language only finds. And the last thing is, look for people worldwide. There are user groups all over the world, and you can keep up on Twitter. You might want to look at some more sophisticated models of data mining projects. I recommend these. This one on the top here was a look at how you might go analyzing the Kaggle Heritage Health Prize. And Thomas did a great job of making it clear about what steps you use and how you overcome some of the difficulties with big data. Of course, we at Revolution, we provide training, and we're happy to assist you however we can. And for my last slide here, I thought I'd indicate some helpful books that I've really found useful. This book in the center here, that really describes the Rattle package, and Graham Williams has done just a marvelous job in building that package and in documenting it with this book. The Art of R Programming is certainly the book to learn how to program from if you want to go further. This book over here is a very nice look at ensemble models, and it uses R to talk about the theory behind those models. ggplot is a graphics package that will help you once you get to doing some more sophisticated graphs, and these other two books I just think are pretty fine references. So that's basically what I had to say, and I hope you've enjoyed my little tour.
Thank you so much, Joe. We have a ton of questions. I don't think we'll be able to get through all of them, but let me end the webinar with just a quick poll, just to get an idea of who's interested in learning more about data mining methods in R. And results are coming in. Pretty clear. I'll go ahead and close the poll and share it. 97%.
That's great.
Yeah. So we have a few questions. We just have a little bit of time. Let's see. The first question comes from Ramon. Do you need a lot of programming experience to be an R programmer?
Well, you need a lot of programming experience to be any kind of programmer, but you don't need a lot of programming experience to use the R language to do useful work. Basically, you can confine yourself to the kinds of simple functions that I've been trying to show today, and you can get the job done. And R is a very friendly in language in helping you, bootstrap yourself from one level to another.
Thank you,
So
Joe.
I, just highly encourage anybody, if you haven't, if you're not a programmer, then this is a language to start with.
Thank you, Joe. This question comes from Steve. Can you use existing R code created in open source R with Revolution R?
Yes, yes. Revolution R Enterprise. What we do is take the R language and make it ready for the enterprise. So if there's a business out there and it needs the most sophisticated tools assembled all in one place, and you need to be able to have a stable environment, then you might want to look at Revolution R Enterprise. But at the center is the open source R. We just take it, we recompile it, we use the Intel math kernel library so it's faster, and then we add, surround it with services and support and some additional code like that RevoScale R package that I talked about.
Great.
But by all means, yes, you've got R when you've got Revolution R.
And Robert is interested in knowing how much RAM we're using in your examples.
Oh yeah, I've got 8. I got a pretty spiffy laptop here. I've got 8 gigabytes of RAM, and I've got 4 cores, and they're dual threaded. So that's why you see these 8 little windows.
Great. There's a few questions about the combination of Hadoop and R, and if you can kind of elaborate on that.
Sure. Hadoop is the ultimate big data store these days, and if you're, why not want to be able to use R and Hadoop together? It's a natural kind of combination. And there's an open source project out there called R Hadoop that Revolution is sponsoring. So there are a number of packages in this project that enable you to work from your R environment and do things like run MapReduce jobs from R in Hadoop. So I encourage you to look at the R Hadoop. It's out there on GitHub, and somebody can direct you to the link for that.
Great. Thank you, Joe. And a few more questions about, if you're a complete newbie to R, what's the best book or resource that you could recommend?
Well, for a complete newbie, what I'd recommend that you do is go to the Inside R website, and I think I mentioned there, and there's actually on here there's a post that you can search for that I wrote on how to learn R, and I've listed not only a couple of strategies and some more books, but also there are data sets on here to get you started. So I recommend starting off with Inside R, and by all means get a hold of Graham Williams' book on Rattle. I mean, that's the way to go.
Yeah, and Joe, the other way, of course, is training. It helps to work with a professor or teacher through our partners, statistics.com, or through some classes that we offer directly. But, if people want help in selecting a couple of training classes to get them up to speed as they're working independently through books and blogs, we can make some recommendations in that regard as well.
Yes.
Excellent.
Absolutely. One final question, and this comes from Christopher. If you have enough memory to handle if you do not have enough memory to handle a large data set, what sorts of tools does Revolution or our enterprise provide, or basically an explanation of RevoScale R and what are the advantages? How does it
Right.
work?
So what we have is this RevoScale R package enables you to work with external memory algorithms. So the package is a number of R functions that don't work in memory. They work on data that's outside of memory. And you can use I mean, on my little laptop here, I can easily process data sets with hundreds of millions of rows.
Great, thank you. For those questions we didn't get a chance to answer, we'll follow up with you after the webinar. At this time, I'd like to thank everyone for attending today. Thank you, Joe, for a wonderful presentation.
My pleasure.
I will send out an email with a link to the R scripts, the presentation, as well as the replay once they're all available. Also want to remind everyone to join us next week, next Wednesday, June 13th, for our next webinar, Finding Meaning in Points, Areas, and Surfaces, Spatial Analysis in R, presented by David Unwin, professor at statistics.com. With that, I'd like to thank everyone and hope you have a great day. Bye-bye.
Bye, everybody.
Thank you, Joe.